finding the shortest route across a network. And the title up the top there is weighted graphs, W-E-I-G-H-T-E-D. Each edge has got a value. It could be time, it could be distance, it could be anything you like, depending on what the network is all about. So there is an example of a weighted graph. Now you can see, apart from the fact that the vertices are labelled, there's also numbers everywhere. So town A to town F is 6 somethings. It could be 6 minutes, it could be 6 kilometres, it could be 6 miles, it could be six bus changes, it could be anything you like. 6 stops on a track, on a network, it could be anything. You're going to get problems in the test like, what is the shortest path from C to F? So on the right across to the left. So you've got to find the shortest path looking at the numbers. So the first way to do it is... Yeah, okay, now what you're doing is you're looking at it and you're doing something called by inspection. That's by inspection, just by looking at it, and usually it's actually pretty obvious which is the shortest path. Now the trouble with that is, first of all, you might miss something, and not in this case, but in a harder one, especially like in a test. Or alternatively, we also actually require you to show there are no shorter ones by showing that all the others are longer. Okay, so and there becomes quite a few, because if you went from C to B, you can then go down to there, we go to there, we can go to there, and from there you can go back up there and across there. There's all sorts of multiple ways of going, all of which are longer. We need you to show that you've analysed it, not just to quickly look at it and say which is the shortest, but also that the others are longer. Now the textbook has the alternative, this thing called Dijkstra's algorithm. Dijkstra was somewhere in deepest Europe, mathematician who came up with this ridiculous way of solving the problem, which has been reproduced in the textbook. And you're welcome to try it if you like. I never found any student who actually handled it, or certainly no teacher. None of us teachers bother with it. But you've got to draw up a table. This is actually not this one here, so doesn't refer to this. But then you've got to amend the table. Then you've got to add something else to it. And then you've got to track your way through the table, and that's not even the end of it, because you're supposed to put little arrows on here as well. So there is an alternative. Last year when I was teaching this, I said, this is ridiculous, I can't handle this, I'm sure the students can't handle it. Along comes Allen's algorithm. This is the problem, and this is the solution, and it involves a process. It looks a bit complicated, but it actually isn't. It involves a process which is almost impossible. Paying attention is very difficult not to get it right first time. There's no sort of mucking about, trialing and erroring or anything else. Now, I don't want you to copy it down, but I'll do it again, and then you can copy it as we go, if you like. I'll do it on the next slide, just to say, we're going from C to F. So there's some features here. From C, there's 2 ways to go. You can either go from town B or town D. So that's what the first row is. And then from B you can go D, E, A. That's what's going on in the diagram. Before you do, just make it clear. When you've got to F, on whichever order you do this, and you found that it's 16 steps to get there, then anything that's more than 16, you can just cross it off. So I can show you that one again if you like. We'll do it here. Just do it here. So we've got to go from A to F. So what would you do first? Right, A at the top. Now, if you've got paper and pencil, I suggest strongly that you actually do this with me at the same time. I'll give you time to do it. So A at the top, and then the 2 ways to go from A are B and C, so you want 2 new nodes under there. Now spread them out. This is why I'm saying do it with me. Spread them out as much as you can, because you need to fill in the bottom, it'll get crowded. So you can go for B or C. That was a 2, and that's a 6. Now remember, you're adding up, so don't write all the numbers in that you're just reading off the screen. So from B, now you can go down to C, and you can go across to D, and you can go across to E. So we need 3 here, because we want to show everything that you can do. So you need 3 off there. You need, from B, you go down to C. Might seem a bit odd to do it, but you've got to show that it's nonsense. You can go to D. This is the order I do things in. I put the 3 lines in, then I put the 3 circles in, and label them. And then I put the numbers in after that. So BC, now BC is 2, so right here, 2 plus 2 is 4. BD is 3, so this will be a 5. And BE is 2, so we have another 4. Now across to C, B and D. Sorry, that's good, thanks for that. Go back to A. You wouldn't go back to A. Never retrace your steps, that can't be right. So CB was 2, so this is now 8, thank you. And CD is 1, so that'll be a 7. And then we keep going. Now remember, we're trying to get to F. Now here's the little, like A, B, E, F. I would put A, B, E, F in, or even though you can go from E, you can go D and F. I would actually go straight to where the answer is going to be, and you'll see why. Put those numbers in. That's 2, which makes that 6. But EF is 3, so we've got a total of 7, agreed? And we've got to F, so you underline it. Cumulative here. So the point is, the reason why I've gone straight to this F here, which is, I think might be the shortest path, it isn't always, is because if this is 7 and I've got to F, then you can cross off that one. You can cross off that one because you haven't got to D yet, and you've already got to 7. So, that makes it easy to finish. This isn't, we haven't finished yet. So we've still got here to go. So we've got A, B, C. Now you can go to D. You could go to D and E, I suppose, if you really had to. Look, don't bother redoing it if you make a mistake like that. Just cross it out. We know that you don't want to do everything twice on one of these. You want to get it right first time. And so A, B, E, D, A, B, E, D, that's going to be too much as well. So basically your answer, what you write down is A, B, E, F. Write it down like this, equal